Okay, I've got a bottle, tube. Water rises in the tube, and if we measure the distance that the water has risen above the level of water in the tube, we can determine how much the pressure in the bottle changed. Now, we could have increased the pressure by squeezing the bottle, which would have increased or decreased the volume in the bottle, and we would have done some work on the gas in the bottle. Or we could have increased the pressure by heating the bottle. So let's think of what happened if we increase the pressure by heating. Now we're just kind of reviewing what goes on in the bottle. By the height of the water column, we can determine the change in pressure. So we could determine, for example, the change in temperature and so forth. So if we raise water in the tube by heating, what happens? What happens inside that bottle? Well, pressure increases. Some work is done against the atmospheric pressure. You got delta W equals P delta V. There isn't much delta V in the case that we increase the pressure by heating, because the only change in volume here is equal to the only change in volume of the gas in the bottle is equal to the volume of the water that was displaced into the tube, and it's a pretty thin tube, only a few milliliters of volume there. Okay, well, what goes on? Again, we're trying to get to what goes on in the tube. And we see that pressure increases. Why? Because the molecules speed up. Now, some people responded that that was momentum. Some people had other responses. Well, the increase is related to the change in momentum. The pressure increases because the molecules speed up, and that increases the change in momentum per collision. It also increases the frequency of the collisions. So if the velocity goes up 10%, let's say, the pressure increase, the pressure per collision will go up 10%, and so will the frequency of the collision. And as a result, it turns out that the force and the pressure, because the surface area is not changing, so if the force increases, the pressure increases by the same proportion. If the force and pressure are then going to be proportional to the velocity times the momentum, and that's then proportional mv squared, which is proportional to the kinetic energy of the molecules. Now, we talked last time about the RMS kinetic energy, the kinetic energy at the root mean square speed and so forth, and you want to think about that. But just getting the general picture, the force and pressure are proportional to the kinetic energy, not to the velocity, not to the momentum, but to the product of the momentum and the velocity. Okay? Again, the product of the velocity and the momentum, because the velocity is proportional to the frequency of collision. And this has all been covered before, so we want to just have the general idea about what's going on in this bottle.